All right, so here we go. These right here that we have, these you know how to solve already. These are the ones that we solved last week. If it's a perfect coordinate, what I mean by perfect coordinate, let me write here what a perfect coordinate is. It's a coordinate on the unit circle. So if it's one of these, if it's a 1, comma, if it's a half, comma, if it's a square root of 2 over 2, comma, if it's a square root of 3 over 2, any other point, 0. If it's a 0, all those, when I say perfect coordinate, that's what I'm talking about. Cool? I guess also you could also include square root of 3 and square root of 3 over 3. I guess you include those as well. And 2 as well. Right? The reciprocal of half. And then 2, and then square root of 2. Well, we'll get there when we get there. All right, so check this out. Ready for this one? So I have cosine theta equals square root of 3 over 2, and I want all the answers between 0 and 4 pi. So what would you do on usually you get theta by itself by doing the inverse. So you write plus minus arc cosine square root of 3 over 2 plus 2 pi n. You don't have to write plus minus on this case because I know which one's going to be the first one. On the unit circle, and I'll go slow, the very first one is this guy. At that coordinate is square root of 3 over 2, comma half. And then I got another one right here. That's square root of 3 over 2, comma negative half. Yay or nay? Yay? Which one's the first one I hit? Yeah, square root of 3 over 2. Which is the first? Cosine of what angle is square root of 3 over 2? Well, 30 degrees, but give it to me in radians because we're in radian here. 1/6 pi, or pi over 6. That's the first one, right? Notice that negative pi over 6 would have worked, but if you add 2 pi to that, the next one is 11 pi over 6. Are we cool with that, guys? And all I'm doing is adding 2 pi. I'm adding 2 pi to the pi over 6 to get another answer between 0 and 4 pi. So I'll put plus 2 pi. Chav, I don't know how to turn 2 pi into, how to add 2 pi without a calculator like this, guys. You see that 2 pi? Just turn it into 12 pi over 6. See, 12 divided by 6 is 2 pi. So 12 plus 1. 13 pi over 6, that's still under 4 pi. And I need one more. The 11 pi over 6 plus 2 pi. 23 pi over 6. That's it. If you go over the 23 pi over 6, you will be larger than 4 pi. How do we feel? Do we feel AWESOME? Awesome. Do you guys have dogs, like indoor dogs? Anyone? And you're like, when you say the word walk, do your dogs go crazy? Like, oh, you're gonna go for a walk, yeah. So that's why when you want to take your dogs for a walk, you tell like, hey, do you want to go WALK the dogs? Because if you say the word walk, they're just like, ah, what? It's like their trigger word. No? Okay, just saying. All right, here we go. Notice this one does not have a perfect radian or perfect coordinate. I shouldn't say perfect radian, perfect coordinate. And I guess all coordinates are beautiful, so I shouldn't say that 0.9 is not a perfect coordinate. But what I mean by perfect, I mean it's not one of these. It's not going to be one of your special angles. So, I mean, I'm not saying that 0.9 is hideous, because it's not. It's a pretty number. But here you go. Ready? I get the theta by itself by doing inverse. So I'm going to write theta equals, and you write plus minus inverse cosine, or you can say arc cosine, of 0.9 plus 2 pi n. And then from there, I can say theta 1 equals, and I take your calculator out, so let me get a calculator. So here is my calculator. I should have had it up already, my bad. Bam, okay. My calculator is already in radian mode because it tells me, it's up there, it says radian. So I'm just going to go second arc cosine, so there it is, 0.9, and I'm going to push enter. So 0.451. So this is what you call a general equation. Theta equals plus minus 0.451 plus 2 pi n. So I'm going to write theta 1 is 0.451 plus 2 pi n. Theta 2, I'm going to write the negative one, negative 0.451 plus 2 pi n. And I guess I should be consistent, so let me write a 0 before that decimal there. I know some science teachers get mad if you don't do that. Will Wentz get mad if you don't put that zero in front of the decimal? Okay, I mean, I don't know. It depends. Maybe he gets rowdy, maybe he doesn't. All right, so now I'm just going to get my answers, guys. So I'm going to write theta equals the very first answer. Remember, I'm looking at answers between 0 and 4 pi. Does anyone know what 4 pi is in decimal? 12.566. Don't worry, I didn't memorize that. I did it earlier. I went 4 times pi. 4 times pi. See? 4 pi, 12.566. Okay, so all I'm going to do is get numbers between 0 and 12.566. The very first one, 0.451. The second one, I take the negative, and I'm going to add 2 pi. So how do I do that? I just put a negative in the front here, like so. I scroll up. I push enter. So there it is, negative that, plus 2 pi. 2 pi. Enter. 5.832. 5.832, comma. To get the next one, take the 0.451 and add 2 pi to that one. So here I am, 0.451. Scroll up, scroll up, scroll up, scroll up, scroll up. 0.451, enter. Plus 2 pi. Enter. 6.734. 6.734, comma. Now to get the next one, go to 5.832. You're just toggling, going back and forth. 5.832 plus 2 pi. And push enter. 12.115. 12.115. And I believe that's it, because if you take the 6.734 and add 2 pi, you're above the 4 pi. Yeah. Plus, if you think about it, 2 pi plus 2 pi, that's already 4 pi, so you can't do more than that. Okay. How do we feel, guys? Yay! All right. Now, check it out. Let me see. Yeah, this one. Yeah, we're just going to do that one normally. Y'all ready? Let me see. Can we do that one without a calculator? Arc, cosine. Nope, because of the 1/3. Okay. So first thing first, I need to get rid of that 3. So let me write it first. 3 cosine pi x equals 1. So I'm going to get rid of the 3 by dividing by 3, like so. Can we do that? Cosine pi x equals 1/3. Next, I'm trying to solve for x. I can't do that with that cosine there. So I'm going to do inverse cosine. So I write pi x equals plus minus arc cosine of 1/3 plus 2 pi m. Are we still all right? I don't know why I said it that way. I'm sorry, guys. Right. I'm going to divide now by pi. Divide by pi, divide by pi, divide by pi. So here's what I have. X equals plus minus. I'm going to write it like this, guys, because it looks prettier. 1 over pi arc cosine of 1/3 plus 2n. x1. I'm going to write my first one there. I take my, bless you. I take my calculator, and I'm going to clear all this, and here we go. Alpha y equals enter. I'm going to put 1 over pi, and then I'm going to move to the right, and then move to the right. Arc cosine of 1/3, and then I'm going to push enter on that sucker. 0.392 if it's rounded, 391 truncated. So I'm going to write 0.392 plus 2n, and then x2, negative 0.392 plus 2n. I'll stop. I heard someone say, stop it. How do you feel? Nothing crazy, right? Okay. Sorry, I just had a random image in my head. Does your brain go like all over the place like mine? I don't think I have ADHD. I promise. I don't think I do. But I for whatever reason, I'm thinking of potassium. And this is a true story. You can Google it yourself. This sounds like a lot of fun, to be honest, TBH. There was a group in New York City. I'm not making this up. I read it online. And there's evidence because there's pictures. This was before iPhone and before Facebook and before, so I don't know how they got organized. And a whole bunch of banana costumes were outside of a restaurant. and they were screaming potassium, potassium, potassium. And then all of a sudden, all these bananas stormed into the restaurant. And you think I'm kidding, but Google it later on, put like bananas storm a restaurant, and you'll see like a whole bunch of bananas inside the restaurant, and you'll see like someone with a camera taking pictures, because back then they didn't have iPhones. And I'm like, oh my God, how did they organize this? They like, this is so awesome. So they must have been university students, and they're like, let's all dress up as bananas and go storm a restaurant. Like, that sounds like a lot of fun. You think I'm making it up, but we'll check it out right now. All right, here are my answers, guys. Sorry for taking you guys on that little journey there. 0.392 is the first answer. The next answer, take the negative and add 2. So I'm going to type negative, and I'm going to push enter on that. And we can probably figure it out if we wanted to, but I'm just going to put plus 2 there. 1.608, and now the rest are simple. 1.608. Chavez, what do you mean the rest are simple? I'm just adding 2. So if I add 2 to the 0.392, that's going to be 2.392. See? Comma. If I add 2 to the 1.68, that's just going to be 3.608. If I add 2 to the 2.392, 4.392. If I add 2 to the 3.608, that is 5.608. And I believe that's it, because if you add 2 to the 4.392, you'll be above the 6. Does that make sense? Cool, right? And that's it, guys. Ya acabaste. That's Spanish for you finished. All right. You guys ready for this one? Okay. Oh, did you say no? Look, this one is not too extreme. At least I hope not. But we'll see. We'll see if it is or not. All right. On the unit circle, where is the y value a half? In quadrant 1 and in quadrant 2. Where's my coordinate a half? In radians. No, not pi over 3. Pi over 6. What's the other one? Yep. So at these two locations. And then. So if you were to solve for this, you would say theta equals arc sine of a half plus 2 pi n. Do not, let me put this here, because it happens every year. Do not insert plus minus. It is wrong if you insert plus minus into arc sine. The plus minus only goes for arc cosine. So Chav, how do I find the answer then? Well, let's do this one first and see if we can come up with a formula. So theta 1, the first answer that you guys think of where sine is a half is pi over 6 plus 2 pi n. Theta 2, the second answer that you guys think of is 5 pi over 6 plus 2 pi n. Are we okay with that? We got that just from knowing the unit circle. Yeah or nay? Okay. No matter how many times, look, let's verify. Sine of 5 pi over 6. 5 pi over 6. Yep. 0.5. Let's see what pi over 6 is in radians. Pi over 6 is that number. Let's see what 5 pi over 6 is. I said what's pi over 6 in radians. Let's see what pi over 6 is in a decimal. Let's see what 5 pi over 6 is in a decimal. So pi over 6, 0.523598 goes on forever. 5 pi over 6 is 2.6179938 goes on forever. No matter how many times I type inverse of sine, no matter how many times I type it, of 0.5, this will only give you the pi over 6. It will never give you 5 pi over 6, even though 5 pi over 6 is an answer. So we got to develop a hack. How do I get the 5 pi over 6? So just listen, guys, so you can take this in. Do you agree that when I type arc sine of half, you just get this answer, this pi over 6 here? Right? So if I type arc sine of this half, look, this reference angle, do you agree that that's pi over 6? So you can get always and forever, you can get that second expression by just doing pi minus arc sine. Don't write that down. Just let that sink in. Because remember, what will this give you? That will always give you pi over 6. If I take pi and I subtract pi over 6, won't that be 5 pi over 6? Yeah. So check it out, guys. Don't write this down. Just listen for now. Look, I'm going to get that 5 pi over 6. Is that 2.61? Look what happens. I'm going to write pi minus, and I'm going to type arc sine of 0.5. And OMG, look at this. That is 5 pi over 6 right there, digit per digit. Do you guys see what I'm talking about? So if you wanted a formula, so I'm going to write right here, guys. If you want a formula, here's your formula. Because I know a lot of you just love your formulas. So here's your formula. Theta 1 is just arc sine of whatever value you got. I'll write x plus 2 pi n. And then theta 2 is going to be pi minus arc sine of whatever value you got plus 2 pi n. And that's how you get your those are your formulas. That's how we got them. How do we feel? Does that make sense to you guys? Okay. So now look at this one. And I know I like 0.9 for some reason. It says, oh, did I even answer this answer? I didn't even answer this one. Sorry, guys. Here we go. My answers. The first answer is pi over 6. The next answer is 5 pi over 6, comma, and then add 12 pi over 6. So 13 pi over 6, comma, then add 12 to 5. What's that? 17? 17 pi over 6, and that's it. If you go another 2 pi, you'll be above the 4 pi. Okay, sorry, that was kind of hard. Not necessarily hard, it's just a lot. Are we still feeling okay? Okay, here we go, guys. Sine equals 0.9. I'm going to go slow. So theta equals arc sine of 0.9 plus 2 pi n. That is my first equation. What's my second equation? What do I write? Yeah, pi minus arc sine of 0.9 plus 2 pi n. There it is. So let's see what that is. I'm going to write it over here, guys. Theta 1 is equal to, and then that was part of that. So theta 1, let me take my calculator here, and I'm going to go second arc sine, 0.9, enter. 1.119769515. Oh, man. 1198. I'm going to put 4 digits. 1.1198 plus 2 pi n. Here's theta 2. I'm doing this one right here. I could do pi minus that, but I'm just going to go ahead and type it in again. Pi minus arc sine. Oh, that's not arc sine. Second arc sine, 0.9. 2.0218. 2.0218 plus 2 pi n. All right, here are my answers. The very first one, 1.1198. 1.1198, comma. The next one, 2.0218, comma. The next one, take the 1.1198, add 2 pi. So 1.1198, enter, plus 2 pi, enter. 7.403, or 7.4029. 7.4029, truncated, because rounded it would have been 403. Take the 2.02 and add 2 pi. That plus 2 pi and 8.305. 8.305. And I believe that's it, because if you take the 7.4 and add 2 pi, that will be over. Whew, that was a little tough, but we're okay. How do we feel, guys? Do we feel okay? Okay. I feel that we're kind of slowing down a little bit, so we're going to stop at this one. This will be the last one we do for today. This one is coming from UH. I believe this was with no calculator before the pandemic. So those kids out there, guys, I wouldn't call them necessarily smarter. They've just been exposed to this type of math. but so are you guys. Look, you guys are being exposed right now. So it wants me to solve for x. And theirs was even easier because it was multiple choice, A, B, C, D. And I think it only has one answer. I want to solve for x for this, and I have no calculator. You ready, Martinez? Are you ready? Ugh. Okay, I'll stop. All right, here we go. I'm solving for x, guys. So let me rewrite the problem. Sine 3/2 x minus 1 equals 0. So the first thing I want to do is I want to move that 1 to the right. So move it to the right. So now I have sine 3/2 x equals 1. The next thing I want to do is do the inverse sine so I can get rid of that sign there. So I'm going to write 3/2 x equals inverse sine of 1 plus 2 pi n. You don't have a calculator, remember. There's the math contest. You're in Houston taking this test on your own. You know this part right here. There's only one answer. This is not going to have two equations. It's just going to have one. What is the only radian where sine is 1? There's only one. It's right smack on the y-axis. What's that radian? Pi over 2. So you're going to write 3/2 x equals pi over 2 plus 2 pi n. Are we still okay? Next, I need to get rid of that 3/2. And you can, if you want, you can say chav, divide by 3/2, which is perfectly fine. Usually when it's a fraction like this, the better term is to say reciprocal. Multiply by reciprocal. So how do I get rid of the 3/2? Multiply by the reciprocal. Whatever you do to one, you do to the other. Does that make sense? So now here's what you have now. You're going to have x equals, let's see, 2 pi over 6, which reduces to, well, I'll go ahead and write it. I know the 2's cancel out and it turns to pi over 3. But remember, we're doing this. And that is 4 pi n over 3. So here's my expression. The 2 pi over 6 turns to pi over 3 plus 4 pi n over 3. They want an answer between 0 and 4 pi over 3. So the only answer that will fit is pi over 3. If I add another 4 pi over 3, it'll be outside of the domain. Does that make sense? Okay. See, you guys can do it. You guys are smart. We can do this, guys. All right. I'm going to go ahead and stop right here. You guys look pretty tired. We are going to continue this on Wednesday. We're going to continue right there, guys. So make sure you get some sleep. Make sure you get some rest. If you haven't finished my work, please turn it in today. And if you've already done everything, then I guess it's your time and you can do what you want with your time. But I would make good use of it. Are we okay, guys? Are we happy? All right, we're done, guys. See you guys later. Oh, well, I can't let you guys go, but yeah. All right. Here we go, guys. So let's go ahead and start. So here's where we left off in your class. So it says, all right, Travis, what about tan? So all we've been doing lately, guys, is just sine and cosine. So hopefully now you're pretty good about sine and cosine. But yeah. So here we go. Tan equals square root of 3. This one is a perfect coordinate. Did I write this down as one of the perfect coordinates? Nope. Square root of 3 is a perfect coordinate. 1 over square root of 3 is a perfect coordinate. Let's see what else. 1 is a perfect coordinate. All right. What I mean by that, guys, is this. Remember that tan on the unit circle is y divided by x. So tan of some angle is your y coordinate divided by x coordinate on the unit circle. Are we still okay with that statement there? All right. The only way to get a square root of 3 is if you're right here. At that coordinate, the x coordinate is a half. The y coordinate is square root of 3 over 2. Or if you're in quadrant 3, where the x coordinate is a negative half and the y coordinate is a negative square root of 3 over 2. Chav, I don't understand. What do you mean? Here's what I'm trying to say. Y divided by x. Square root of 3 divided by 2 divided by a half. Notice that the 2's cancel, and you're just left with square root of 3. If I had both of them negative, notice that negative divided by negative is a positive. Do you guys see that? So there it is. So I'm going to write x equals inverse tan or arctan of square root of 3. And this one repeats every pi degrees, or pi radians, sorry. 180 degrees or pi radians. Chav, I don't understand how. Notice that this is a linear line. So to go from this one here to this one, all I'm going to do is add pi. Do you guys see that? If you're in degrees, you're going to add 180. And if you're in radians, you're going to add pi. So here are my answers. X equals arc times the square root of 3. Bless you. The very first one is pi over 3 at 60 degrees. The next one is this one in quadrant 3, which is 4 pi over 3, comma. The next one, all I'm doing is this, guys. I'm just turning that 3 pi n into, I'm just turning the pi n into 3 pi n over 3. So I'm just adding 3 to the numerator. So 4 plus 3, 4, 5, 6, 7, 7 pi over 3. And I think I have one more. 7 plus 3, 10 pi over 3. And that is smaller than 4 pi because 4 pi, if I were to keep the denominator 3, would be 12 pi over 3. 3 goes into 12 4 times. So we're good. Those are my 4 answers. How do we feel? Nothing crazy, right? Pretty simple? All right. Let's look at this one. And you're like, Chav, I don't know. Relax. Let's go slow. I'm trying to solve for x. First thing you're going to do, move the 1 to the other side. So they're telling me that all my x values better be between 0 and 7 pi over 3. So I'm going to write this. Tan 6/7 x equals negative 1. Are we okay so far? Then I'm going to go ahead and do inverse tan to get rid of that tan there, guys. So I have 6/7 x equals inverse tan of negative 1 plus pi n. Are we still okay? All right. On the unit circle, tan, if this was not a perfect coordinate, I would just take my calculator and do it real quick on that one. But it is a perfect coordinate. Tan is negative 1 in quadrant 2 and in quadrant 4. But I don't have to worry about quadrant 4 because quadrant 2 plus pi will get me the quadrant 4 one. This happens, let's see, negative square root of 2 over 2, square root of 2 over 2. Y divided by x will give me negative 1. Do you guys see that? This radian is 3 pi over 4. So I'm going to write 6/7 x equals 3 pi over 4 plus pi n. And now what I'm going to do to get rid of that 6/7, you can say divide by 6/7, but it's probably best to say multiply by 7/6. Whatever you do to one, do to the other. So multiply by all those dudes by 7/6 there. So here's what you're going to get, guys. X equals, and I'm going to have, let's see, 7 times 3, 21 pi over 6 times 4, 24 plus 7 pi n over 6. And I know this reduces. What goes into both? 3 of them? So 3 goes into 21 how many times? 7 times? So 7 and 3 goes into 24 8 times. So there it is. And now maybe what you're thinking is, Chav, how am I supposed to get all the answers between 0 and 7 pi over 3? I don't know how big this is. Relax, guys. Look how simple this is. You see how this denominator is a 6? So all I'm going to do is I'm going to turn that 3 into a 6. So I'm going to multiply this dude by 2 over 2. That's multiplying by 1. So I haven't changed the magnitude of it. And look what you get. 14 pi over 6. So this is between 0 and 14 pi over 6. Well, notice 2 of these would give you 14 pi over 6. Do you guys notice that? So that means I'm only going to be able to do it once. And that's it. Because if I do it twice, then I'm going to be outside this 14 pi over 6. Cool or not cool? So here's my first answer. 7 pi over 8. Almost a whole pi. Or 7/8 of a pi. The next answer, go ahead and add 7/8 plus 7/6. You can do a common denominator if you want. Times 6 times 6 times 7 over 7. I'm just going to tell my calculator here. 7/8. What was it? 7/8 plus 7/6? Plus 7/6. And I'm going to push enter. I'm going to turn it into a fraction. And there it is. 49 pi over 24. 49 pi over 24. And that's it. You're done. Those are the only two. Do you see how we did it, guys? Okay. Here we go. We're going to need a calculator for this one. 100%. I'm going to solve for x. I'm going to go slow. I know it's a little warm in here, guys. And if you guys ate a lot, you're probably a little tired. x equals arctan of 0.25 plus pi n. Excuse me. I'm going to tell the calculator arctan of 0.25. I take my calculator. I'm going to go clear. Arctan 0.25, and I'm going to push enter. 0.24497 or 98. X equals 0.24498 plus pi n. So my answer is, one of them is that, 0.24498. And because it's between 0 and 2 pi, the other answer is plus pi. So 3.14 plus 2.24. Let me see what that is. Plus pi. Enter. 3.3865 or 66. 3.3866. Done. That's it, guys. How do you feel? Okay. So what are you going to do today? You're going to have a delta. And these are the questions. Oh, we're not there yet. Sorry. After we do these two, we'll be there. Okay. Let's keep going. Don't worry. We're going to finish these really fast. And you don't feel like it's too much, right? Okay. Your calculator does not have a button for cosecant, or maybe you do if you have an Inspire, but you, the TI-84 does not. And relax, you don't need it. And even if you're wondering, like, oh, in that case, I'm going to get an Inspire. If you're putting the Inspire in testing mode, you lose access to the cosecant button. So it's better to know the logic behind it. Okay, what are you going to do? I want to get cosecant x by itself, so divide by square root of 2. So you're going to have cosecant x equals 2 divided by square root of 2. Can we do that first? Next, cosecant's a reciprocal of which one? Sine. So I'm going to write sine x equals square root of 2 over 2. I don't have to do any of the tricks that we did last time. I think we did some tricks with like pi and pi minus whatever. Yeah, there it is for the arc sine or for the sine. We don't have to do any tricks, guys, because square root of 2 over 2 is a perfect coordinate on the unit circle. Where is sine of square root of 2 over 2? It happens in quadrant 1 and in quadrant 2. Perfect. X equals, the one in quadrant 1 is pi over 4. Is that what you said? And the one in quadrant 2 is what? 3 pi over 4. And because they wanted the answer between 0 and 2 pi, that is it. How do you feel? Do you feel good? Yeah, okay. Look at this next one. Because of that 4 on the inside, it's gonna, what does that 4 do? It's gonna horizontally compress my sinusoid or your cosecant here. So here we go, guys. Ready? Cosecant 4x. Cosecant's a reciprocal of sine. So keep the argument. When I say argument, I mean this inside the parenthesis here. So you're gonna write sine of 4x, and you're gonna take the reciprocal of negative 2, negative half. Are we still okay? Now we're going to do the inverse. So check it out. 4x equals arc sine of a half, of a negative half, plus 2 pi n. So here's my first equation. Actually, you don't even need a, yeah, let's do first equation. 4x1. On the unit circle, which is the very first radian where you hit a negative half. So let's do a visual for you guys. This one, is, we're talking about, oh, that's a positive half. It's either this one down here or that one down there. What's the one in quadrant 3? The denominator is a 6. Yeah, 7 pi over 6, guys. 7 pi over 6 plus 2 pi n. And here's the second equation. I'm going to do it in blue. 4x2 equals, in quadrant 4, it's not 7 pi over 6. In quadrant 4, it is 11 pi over 6. Good job. I heard someone say it, but they just whispered it. How do you feel? All right, that's it. We're pretty much done. Divide by 4, and here's it's not really a hack, but I see some of you struggle when you divide fractions. Here's how you divide it real quick. Ready? Divide by 4, divide by 4, put it next to that 6 there, divide by 4. See? x1 is equal to 7 pi over 24 plus pi n over 2. And I'm going to do the same thing with this blue one here. Divide by 4, just put the 4 next to the 6. Divide by 4. So x2 equals 11 pi over 24 plus pi n over 2. I want all my answers between 0 and 2. So we're just going to kind of use our little brains a little bit just to think about what the magnitude of that number is. So here we go. X equals, so my first answer is 7 pi over 24. Yeah, that sounds correct to me. 7 times 3 divided by 24. 7 times, because pi is like 3.14. 7 times 3, that's like 21. 21 over 24 is definitely a number between 0 and 2. It's like a number a little bit smaller than 1, right? 21 over 24. Then 11 pi over 24. 11 times 3, that's like 33. 33 divided by 24, that's a number between 1 and 2, between 0 and 2. So 11 pi over 24. Do you see how we did it, guys? Now, I think this part might be a little tricky. Let's see. If I have a 24 down there, I'm going to multiply this by 12. 12 over 24. What's 12 plus 7? 19. 19 pi over 24. What's 19 times 3? 20 times 3 is 60. So 57. 57 over 24. 24. Yeah, that's going to be bigger than 2, right? It's out. There it is. It's just those two. Do you see how we did it? You can always just take a calculator. Because look, it says between 0 and 2, guys. You can always just take a calculator and just literally just go 19 pi over 24 and see what that number is. And look, it's bigger than 2. Cool? Yeah, you guys don't look impressed. You guys are like, okay. All right. Everything we just talked about is in this page right here. Here are the formulas. Now, in a little bit, when you do your delta, I kind of like the reference angle route better than this route. You guys okay over there? Yeah, don't cry. Okay, sorry. Hallelujah. I wish I had a button that I can push that fire would come out. Just that. What if we were to go to a Taylor Swift concert, but instead of her singing, it would just be her doing math problems? And it would be this. No, it would be yawning. Everyone would be like, yeah, Taylor Swift, do that, solve that sinusoid. Okay, here we go. Here's what you're going to see today. I'm going to go slow, and hopefully this is entertaining for you. So we're going to go through these problems really fast. I want you to look at this problem really quick and tell me, what do you see different from the other ones? It's in what? Oh, yeah, they put a B in there. And then tell me, look at this right here. It's in degrees. So change your calculator to degrees. So go to your calculator. And if it says radian, if you have one of the new ones, make sure it says degree up there. If you have one of the old ones, you're just going to have to go to mode and change it. So now mine says degree. Does yours say degree also? Yes. All right, here we go. How do you solve these? You get all the tans by themselves, and you get everything else to the other side. So you're going to do this, guys. I'm going to move this tan b to the left. I'm going to move that negative 14 to the right. So when I move that tan b to the left, I'm going to subtract 1. So negative 5 tan b minus 1 tan b is negative 6 tan b. So negative 6 tan b. Is everyone okay with how I got negative 6 tan b? All right. And then I'm going to move that negative 14 to the right. So I'm going to have 14 minus 7. So I'm going to have 7. Is everyone okay with how I got the 7? Okay. All I did was plus 14. So 14 minus 7. Next, I need to get rid of that negative 6. So what do I do to get rid of it? Yeah, divide that sucker. So now you're going to have tan b equals negative 7 over 6. You can put the negative wherever you want, but negative 7, 6. That's fine. Now, how do I get the b by itself? The inverse, yeah, I and v. That's what you said, right? Yeah, no, it's okay if you didn't miss. Inverse tan. Because, by the way, this is called an argument, guys. Tan of b. So this is not tan times b. It's tan of b. So to get rid of the tan, you got to do the inverse. B equals inverse tan of negative 7/6. Now we're in degrees. I would usually put plus pi n. But because we're in degrees, I'm going to put plus what? 180 n. All I'm doing is this right here. Look, all I'm doing is that. Right there. So I take my calculator. I don't know what arctan of that is. So I'm going to take my calculator. And it's in degree mode. I'm going to clear it. Second arctan, negative 7/6. I push enter. Don't worry, I'll come back up. Negative 49.4 because it says nearest tenth. So B, this is what you call a general equation. Negative 49.4. 49.4 degrees plus 180 degree n. All right, let's find all the answers. B equals negative 49.4 is not in the domain. So all I'm going to do is add 180 to this number. Enter. There it is. 130.6. 130.6 degrees, comma. And let's add one more 180. So I'm just going to push enter. And look, it does it for me automatically. 310.6. And that's it. Cool or what? You guys don't think that's cool? Yeah, I know. I've noticed that too. There's a ghost. It's giving the fan a resurgence or something. All right, let's continue, guys. Look at this one here. Find all angles between 0 and 360 that satisfy the equation below. Start by moving the square root of 3 to the right. 2 cosine theta equals the negative square root of 3. And then I'm going to divide both sides by 2. Cosine theta equals negative square root of 3 over 2. Hopefully you're applauding at the moment because this is a perfect coordinate. So on the unit circle, where is cosine negative square root of 3 over 2? It's going to happen at that one and that one. Do you guys remember what that degree is? 150 degrees. Good job. And then the other one is 210. And done. That's it. You don't even have to do this one because it's so easy. There is a unit circle quiz coming on Friday, so make sure you are prepared for that one coming up. It's in video, so it's for the record. Bam. Harry Styles will also be here as a Thanksgiving treat to tell you guys goodbye for the week. So be here. What if he was? What if he was here? What if I really did know him? I don't know. All right, here we go. This one you're going to need your calculator, guys, because this is not going to be one of those perfect coordinates. So here it is. Move the 1 to the other side. So you're going to have 3 cosine theta equals 1. And then I'm going to divide both sides by 3. So cosine theta equals 1/3. And now to get theta by itself, I have to do inverse cosine. So theta equals, put the plus minus, that's part of the cosine one. Arc cosine of 1/3 plus, not 2 pi n, because I'm in degrees, so I'm going to say 360 degree n. From being in degree mode, every time I do a revolution, I'm in the same location. Oh, for tan repeats every 180. See, if we scroll up to the other ones, or look, you can just look at this one. It says right here, arc cosine. Arc cosine is 360. Arc sine is 360. But the arc tan is 180. So we're not robots, guys. Make sure you know where they're coming from. The arc tan repeats every 180. The sinusoids repeat every 360. And no yawning, that's under demerit. The next one's a demerit, miss. Theta equals. All right, here we go. I take my calculator. And I'm going to go, I'm going to clear this. And I'm going to go second arc cosine. I'm going to put 1/3 in there. 1/3. I'm going to push enter. And I get this answer, 70.5. Was it a 1/3 or a negative 1/3? No, it's a 1/3. So theta equals plus minus 70 point, did I say 5? Yeah, 70.5. Plus 360 n. So my first answer is 70.5 degrees. The next answer is the negative plus 360. So I'm going to go back to my calculator. I push the negative. I scroll up. I push enter. Plus 360. I push enter again. 289.5. 289.5 degrees. And that's it. Because if you take the 70.5 and add 360, well, you're be above outside the domain. Cool? Okay. All right. The next example, we're almost done, guys. We're almost done. 3 secant theta plus 7, move the 7 to the other side. So you have 3 secant theta equals negative 7. Now I'm going to divide both sides by 3. Secant theta equals a negative 7/3. Have we ever done a formula with secant? No. So we're going to turn this into cosine. Why cosine? Because secant is the reciprocal of cosine. So you're going to write cosine theta, and you're just going to take the reciprocal. Negative 3/7. See? So theta equals plus minus arc cosine of negative 3/7 plus 360n. Here are my answers. Theta equals, that's a 3/7 there, right? So here we go. Arc cosine, I'm going to clear this. Second arc cosine, negative 3/7. Push enter. 115.4 degrees. That's my first answer. 115.4 degrees, comma. The next one comes from the negative of that plus 360. Negative enter plus 360. Enter. 244.6. Done. How are we feeling, guys? Are we feeling okay? Say it again. Yeah, I added 360 to the negative 115.4, sorry. Because remember I have a plus minus right here? So it was plus minus 115.4. So theta equals plus minus 115.4 plus 360n. So one answer is just a positive 115.4. Then the other answer, you take the negative one and you add 360. All right. I'm going to take a quick pause to give you a disclaimer on this. If you are weak with factoring, we are going to have an issue here. If you are weak with factoring from your Algebra 1 and Algebra 2 days, guys, we have 3 more days left, Wednesday, Thursday, Friday. Come in, and we will do a whole bunch of factoring. Cool? So I will show you how to do this, and hopefully everything will come back to you. But if you have issues with factoring, you're going to have a hard time. All right, here we go. I want to solve for these. This is similar to saying 5x squared minus x equals 0. How would you solve that when you were in Algebra 2? You would factor out an x, and you would have 5x minus 1 equals 0. You guys remember that? And then you would say, well, the only way this will equal 0 is if x is 0. 0 times anything is 0. Or if 5x minus 1 equals 0. See, move the 1 to the other side, divide by 5, x equals 1/5. So it's either this one or that one. If x is 1/5, you'll get 0. Does that make sense? Okay, it's the same thing, guys. You're going to factor out a cosine theta. Okay, so quick record. Cosine squared theta means, parenthesis, cosine theta squared. That's what it means. It does not mean this. Cosine squared theta does not mean cosine theta squared. It does not mean that. This means that theta is being squared, the argument, while this means that cosine theta is being squared. Do we understand the difference? This is called an argument, guys, the theta. It's like when you're saying f of x, you usually don't say f, you just don't say, oh, it's f. You say f of x. So it's like saying that. Okay, here we go. I'm going to factor out a cosine theta. So cosine theta, parenthesis, and you're going to have 5 cosine theta minus 1, close it, equals 0. Is everyone okay with how we got that? All right. Then I'm going to write this. The only way this will equal 0 is if cosine theta equals 0. So on this, we don't have to do any work. On the unit circle, where is cosine theta equal to 0? When the angle is on the y-axis, what angle is that? 90 degrees. Or when you're in the negative y-axis, what angle is that? 270. Those are two of my solutions. Now I'm going to figure out this one here on the inside. I can have the expression 5 cosine theta minus 1 equals 0. Move the 1 to the other side. 5 cosine theta equals 1. Divide by 5. Cosine theta equals 1/5. And now we're going to take the, bless you, we're going to take the inverse of that to get theta by itself, guys. Theta equals plus minus inverse cosine of 1/5 plus 360n. Make sure that you put the degree symbol where applicable. Here we go. I take my calculator. I'm going to go second arc cosine. Was it negative 1/5 or just 1/5? 1/5. 1/5, push enter. Plus minus 78.5 degrees. I'm not going to put that. I'm just going to go right to the answer. Theta equals, one answer is 78.5 degrees. 78.5 degrees. Comma. The next answer, that's a comma, not a semicolon. The next answer, take the negative of this guy. I'm going to add what to it? 360. Enter. 281.5. 281.5 degrees. And I believe that's it because it's between 0 and 360. So here are your four answers. It is this two right here and these two. How do we feel? Okay. Look at this one here. I'm going to go slow, guys. I have tan squared theta plus 3 tan theta equals 0. I'm going to factor out tan theta because that's what Justin Bieber would have done. So I'm going to write tan theta plus 3. I'm pretty sure he knows this. No, I'm positive he knows this. So does Harry Styles. He knows this too. And then I'm going to say, all right, where is tan theta equal to 0? So that one's a simple one. Remember that tan is y divided by x. So I want the y to be a 0 and I want the x to be a 1. So that happens at 0 degrees, because it's 1, 0. Or it also happens at 0 divided by negative 1, so 180 degrees. You guys see that? And it also happens again, because there's an equal sign, 360 degrees. So that takes care of that one. Now let's take care of the other dude, the tan theta plus 3. So I'm going to write that one up here. Tan theta plus 3 equals 0. Move the 3 to the other side. Tan theta equals negative 3. Do the inverse tan. Theta equals arc tan. This does not have a plus minus. Negative 3 plus. This one, I mean, it also repeats 360, but the better answer is repeats every 180 degrees. Yay or nay? All right, then we're going to go to our calculator, and we're going to go, eventually it's going to be voice activated, and you're just going to go, calculator, inverse tan, negative 3. But right now it's not voice activated, so you got to type it out. We're 10 years away. There will be a calculator that will be voice activated, guys, in time. We're not there yet. We're about 10 years away. So 10 years from now, a decade from now, you know, that's what you're going to have calculated or voice activated. Arc tan of negative 3, enter. Negative 71.6. I'm going to write this down as my general equation. Negative 71.6 degrees plus 180n. Here are my answers. I'm going to add 180 to that dude. Plus 180. Enter. 108.4. That's an answer. 108.4 degrees. And I'm going to add another 180 to that. I'm just going to push enter. Enter. 288.4. 288.4. And that's it, because if I do another 180, it's going to be above. So these two coupled with these three. Cool? All right, I need your A game for the last one. This is it. This is the last one. I don't think there's any more. Yeah. I need your A game for this one. This one, you're going to have to factor this one either with the AC method, factoring by grouping, or guess and check. So I'm going to write what this is similar to. Similar to let's see, negative 6x squared minus 2x plus 2 equals 9x. When you guys had that in Algebra 2, excuse me, were you guys able to factor that out? Super awesome. Say yes. Heck yeah. Heck yeah, you were. Math life. 24/7, all the time. Nothing but math life. Forever and ever. Okay, I'll stop. Before I get too hype here. All right, here's how you would do it last year. Negative 6x squared. Move the 9x to the left. So negative 9 minus 2, that's going to be negative 11x plus 2. And I got nothing on the right-hand side, so I equal that to 0. So you either did guess and check from here, or you did factoring by grouping. I'm going to take a guess that you did factoring by grouping. Let's go ahead and, you see how it starts with a negative? Let's make it start with a positive. Child, what are you talking about? I'm making it look like this. ax squared plus bx plus c equals 0. I'm making it look like that, guys. 6x squared plus 11x minus 2 equals 0. All I did is divide everything by negative 1. Are we okay? All right, here it is. AC method. 6x squared times negative 2. That's going to be a negative 12x squared. Two numbers that when I multiply give me negative 12x squared, but adds up to a positive 11x. Yeah, I heard someone say it or kind of whisper it. 12x times a negative x. Isn't 12x times negative x negative 12x squared? And isn't 12x minus x 11x? So then I'm going to factor by grouping. So check it out. Here's what I'm going to do. I'm going to put this over here. I'm going to write 6x squared plus 12x minus x minus 2. All that equals 0. All that stuff equals 0. Sorry. Are we okay? All right. Here's what I want you guys to see. I'm going to group these two. I'm going to group these two dudes. I'm grouping them in binary or in binary pairs. Cool. What can I factor out of the first two? Yeah. If I factor out a 6x, I'm left with x plus 2. That's what I want to get again. So what can I factor out of the next two? A negative 1. And look what you have. OMG, x plus 2. Don't be a robot. Think of this as, it's a product. And think of that as a term and think of this as another term. What do both of those terms have in common? An x plus 2. An x plus 2 factor. And if you factor out the x plus 2, what do I have on the outside left? There it is. Child, but why does it work? Well, let's see why. 6x times x, is that 6x squared? Bam, check mark. 6x times positive 2, is that 12x? Check mark. Negative 1 times x, is that negative x? Hell yeah, it is. Negative 1 times positive 2, is that negative 2? Heck yeah, it is. And this expression happens to be this expression. See how it works, guys? Isn't that awesome? Okay. Now you're probably saying, all right, Chav, how does this relate to that? Guys, this is a similar problem. This is similar to this. The only difference is I'm going to replace the x's with the word tan theta. That's it. That's the only difference. So I come back and here's how I write it. I'm going to write parenthesis 6 tan theta minus 1, close it, parenthesis tan theta plus 2, close it, equals 0. See? And then I solve. I say, okay, the only way this will equal 0 is if this expression is 0. So I go 6 tan theta minus 1 equals 0. And then I just solve like all the others. Move the 1 to the other side. So 6 tan theta equals 1. Divide by 6. And I'll zoom in here. So divide by 6. Let's see. Tan theta equals a 1/6. And then I'm going to do inverse tan. So theta equals arctan or inverse tan of 1/6 plus 180n. I'm going to call that theta 1. And then I'm just going to put the answers for that one, guys. So I'm going to write theta 1 equals, so I'm going to take my calculator, and I'm going to go arctan, second arctan, what was it, 1/6? 1/6, I push enter, and I'll say, hell yeah, math life, 9.5. So I put 9.5 degrees plus 180n. So let's see what my answer is on this one. 9.5 is one answer. And if I add 180, can I add 9 to that? 189.5. I'm assuming I know how to add. And if I add another 180, I'm above 360. So there's one of them. Now let's do the second one. I'm going to do the second one in blue. So let's see. I'm going to do it. Oh, look, I got a lot of space over here. So I'm going to write tan theta plus 2 equals 0. Move the 2 to the other side. Tan theta equals negative 2. Do the inverse again. Theta equals inverse tan of negative 2 plus 180n. See? And now we're just going to type that into the calculator and see what joy it gives us. So I'm going to go second arc tan. Is it negative 2? Yeah. Ask your parents for a calculator, guys, for Christmas. Well, okay. No, I'm being serious. When I was a high school kid, I did ask my parents for a calculator, and I did get a calculator for Christmas, and I was so happy. Negative 63.4 degrees plus 180n. All right, let's get the answers. So I'm going to add, what am I going to add? I'm going to add 180 to that. Plus 180. So that's one answer, 116.6. So theta equals 116.6 degrees, comma, and another answer is, add 180 to that, so I'm just going to push enter, 296.6. 296.6. And there it is, guys. Those two answers coupled with these two right here. I do not see any errors. Look how this beautiful math. Zoom out and admire all the beautiful math you guys just did. Did you guys ever think you guys would be doing stuff like this? But now, look at you. Now you are winning at life. You are winning in academics. You are winning at math. So you should be very proud. Yeah. Did you guys just say I'm going to take stats next year? What's wrong with Cal? But look, it can be done. Look at all the people who have come before you who have done it. And those are qualifying scores, guys. Those are not just people who are on the class. All right, we're done. There might be another example on Delta that I might do for you guys if we don't understand it. But I hope not. But if we get there, we'll do that again. Log into Delta. You're going to see an assignment. I'm about to post it up right now. One last problem. Do you guys see this problem, guys? I'm about to zoom in on it so you guys can all see it. Do you want to write it down somewhere on the side of your notes somewhere? All right. Because we didn't do one of these with you guys, so that's why we're doing it one really fast. We did sine, but we did it with radians. So here we go. This is in degrees. And I think Delta's route does it with reference angles, which I actually kind of like it, but since we already showed these formulas, that's fine. All right, move the sine c to the left. So we do that by subtracting 1 sine c. So that means I have 3 sine c equals, and then move that plus 3 to the right. So 1 minus 3, I believe that's negative 2. Yes or no? And then I'm going to divide both sides by 3. So then I'm going to have this. Sine c equals negative 2 over 3. And then to get c by itself, I'm going to do inverse sine. C equals inverse sine. Notice that there's no plus or minus in front of it. Of negative 2 over 3 plus 360n. Now, I don't know if you remember. Look back at your notes. The second equation came from doing pi minus arc sine. But we're not in radians. We're in degrees. So my second equation, my C2, is going to come from doing 180 minus arc sine. And this will give you all the answers. You could also do it with reference angles if you want to do that route. If you want to go with reference angles, just take the negative out and then just check where you are at. Like check what quadrant you're at. The only quadrants that's going to give you a negative answer is 3 and 4. So you can do it that route. So check it out. I'm going to type it into the calculator. Here's my calculator. I'm going to go second arc sine with a negative 2/3. Negative 2/3. Enter. This is one answer. They don't want the negative one, so I'm going to put plus 360. So plus 360. So one answer is 318.2 because I think it said nearest tenth. So tenth of a degree. Yep. So I'm going to put a plus symbol. 318.2 degrees. All right. What's the next answer? The next answer according to this, look what I wrote. I wrote 180 minus that. So on your calculator, you're going to go 180 minus, and it will work if you do that one, but I just scroll up to the very top one. I just go that, and I push enter. Hold on. 180 minus, scroll, enter. And then look, enter. 221.8. That's it. You're done. 221.8. And then I push submit, and look at this. Are you sure? Yes. Look, it's right. They do it with reference angles, guys. And I actually like the reference angles route. If you want to go that route, just take the negative out, and then just remember where you're negative, quadrant 3 and 4. So 180 plus the reference, 360 minus the reference. That will get you those two angles. Whatever you like. If you like that route, do it that route. If you like this route, which, you know, almost everyone was doing it this way in first period because they have the formulas there, then do it this route. Does that make sense to everyone? All right, guys, that's it. Let's get to work. And if you have questions, let me know. You guys did a good job today.